Good morning. Try that again. Good morning.
Good morning.
Good morning.
Okay. Let's share the screen. Okay, a couple notes. I believe all the homeworks are up now and you have all the dates. So if you are one of those people who are able to work ahead, I would recommend it, right? Get rid of this stuff while you can, so that you can do project things. And I've also posted the P0, which is the description of the project, P1, which is your first deliverable, it's the proposal, it's a one-pager, and then P2, which is the beginning of the software design document. And on Friday, we'll devote Friday to talking about the project. And from here on out, every Friday is project day. A couple of those, when you start to have deliverables, I'm going to ask you to do peer review stuff, so it won't be in the lecture. It will be things that you do during the week where you're sharing your work with other people and they're commenting on your work. Again, one of the themes of this course is to learn to share your unfinished work with people to get feedback early. Share all the ugly stuff rather than trying to wait until it looks good before you want to share it with anybody. If you can drop your ego a little bit, you can get a lot better product out the door. In professional world, that means product. Good product means money. In academia, a good product means good grade. So it's a beneficial thing to share your work. How are labs going? I'm going to take silence as consent that that's going well, or at least sufficient.
Yeah, it's pretty straightforward.
Okay, yeah, and again, there are times available to. I missed it. There are times available to get help with labs, but there is no required lab time. Again, all of these live lectures are optional because since it's online, it's a guarantee. If I were to make any lecture time required, somebody would have a conflict and be unfairly disadvantaged compared to other students. So we want to keep a level playing field here. Okay, so all we're doing today is walking through code. I'm going to go back, even though I did this first circle the other day, I'm going to do it again. Remember, classes are composed of attributes and methods. The attributes describe the state of the object, and the methods are used to modify or to report on the state of the object. And so if I do this first circle piece of code, all I'm doing here is giving you, okay, here's how you can declare variables, here's how you can assign values to variables, here's how you can print out results. We'll do this fairly quickly because of the, we went over it on Monday. Since Monday, maybe you have attempted to do the programming assignment though, and you have questions that you didn't think you were going to have. This is the exact right time to ask those questions. And I prefer that you just unmute yourself and ask the question, but if you want to do them in chat, that's fine too. Okay, so attributes and methods. Attributes go here. Once we define the class, attributes go here. It always starts out public, class, name of the class. That's how you're always going to start these things. Public, everybody can see it. Class, we're telling the compiler that we are defining a class, and the name of this class is first circle. First circle class has to be stored in a file right there named firstcircle.java. Those two have to match. Yes, capitalization matters. It's frustrating when you're, oh, this thing won't compile, it won't compile. Oh, shoot, I screwed up capitalization. That's a frustrating error to make. So this thing, this class, now once you do public class first circle, the class is going to be fully defined within these brackets. If I start typing down here, and then I try to compile that, I will get an error. I better get an error. Everything goes inside the class. We have no attributes. So it's really a lousy object, right? No attributes. And we only have one method, which is main. Now, basically what I'm doing, even though I put this inside of an object, this is programming in the old imperative style. This is programming like you did in MATLAB and programming like you did in your C class, pretending that objects don't have any meaning. And quite frankly, when object-oriented paradigm first came out, there were a lot of programmers like me who grew up with Fortran and grew up with C. And then we had to learn this new thing. And you know what we did? We put our whole code inside main and said, ta-da, we're object-oriented. And of course, it was not true. It took a while to retrain us, guys. All right, now we do declare some variables here. And why am I calling these variables and not attributes? What's the difference?
They're not in the class.
They're not, right, exactly. They're inside of a method, right? They don't belong to the class, they belong to the method. You will almost certainly create temporary variables inside methods. There is absolutely nothing wrong with that. It's normal. Now, in this case, we won't need that, but that's okay. All right. And the way you declare these things, because they're not attributes, I'm not going to put private in front of it. I'm just going to say, here's the type of data that I'm dealing with. It's an integer, int integer. Integer, x location, y location. As a program designer, you have to think about what kind of data you have. X location and Y location, using integers for that, quite frankly, if I really needed to do this as anything other than a class example, I would not use integer. I think it would be too limiting. I was going to say stupid, but it's too limiting. That sounds better, right? And then I'm just showing you the integer data type. That's all. And then double. Double means it's still numeric, but it's no longer an integer. Now, why is it double? Well, the history of that term is that it used to be something called float. And the reason is you could float the decimal point around. That's where float came from. And then people found out as more and more computation was occurring, there weren't enough bits. The length of the float type was not long enough to handle all the numbers that people wanted to handle. So they made it twice as big and they called it double. So that's why double. You don't really need to know that. You just need to know that it's still numeric, non-integer. So you'll notice when I assign x location a value, because it's integer, I don't use decimals. And when I assign radius a value, I do use a decimal point. Now, what would happen if I did 20.0 here for the x location? Here's how you find out. Compile it and run it. I'm going to save this.
Error.
Now, yeah, so here's the answer. The answer is it depends on whatever language you're working with. A lot of languages will just truncate it to 20. Let's see what Java does. I'm going to change my directory because, again, I'm working in console to CS225, M02 module 2, and then I'm going to do Java C first circle.java. and it says, by the way, these error messages really tell you what's happening. Incompatible types, possible lossy conversion from double to int. Now, it may still run. Let's see, my first circle class is at 1:48 p.m. Yeah, on Monday. So no, it didn't even make the class file for me. It said that's a true error. Sometimes you'll get warnings instead of errors. It's a true error. You're not allowed to do that. So let's get rid of that. Save it. Compile it again. Hopefully that works. Okay, and then let's run it. And all it does is do what we told it to. The other thing to look for in this code is the print statements. I'm using print ln, which is print line, which means by the time it prints that, it automatically gives me a line feed and goes to the next line. If you don't put that in, it'll just keep printing out on the same line, and sometimes that's what you want. You can do a print statement that only has things in quotation marks, so that's just a string that gets pushed out to the console. Or you can do only a variable or an attribute, and it will push that value out. By the way, that's almost always a bad idea. You should always describe what you're printing. If you want to do both, then you use the plus operators, which is going to concatenate all these things together. So in order to get the, if you look at this output there, circle center is at left parens 20, comma 15, right parens, period. I have to embed all that stuff in here. There's my comma, and there's my right parens, period. There are more sophisticated ways to do this that we don't need to worry about now. It's called printf, and the F is for formatting, and then you have to learn some formatting rules. But for now, the print ln will work for 90, 95% of what you need to do in this course, and maybe even in all your programming. You are also allowed to perform computations right inside the input. That's true all the time, by the way. It's when is it a good idea, when it is a bad idea? That's a program design choice. That's a style choice. If it is making things unclear what you're doing, you probably shouldn't do that. We'll talk as we get more and more into the actual object-oriented paradigm about the use of methods. And instead of putting a raw calculation in that spot, I almost certainly would use a method call. And I'll have examples of that later on in about 2 weeks, I think. Okay, do we have questions about first circle?
So I'm trying to mimic the code in the Notepad++, and
Yeah.
mine won't turn the green and purple. It's all black. Is there a setting I need to change?
Language.
Okay.
Language, and under J, there's Java.
Okay, thank you.
Yep. And notice how many languages this thing supports. We always talk about MATLAB, C++, Java, and Python, but there's thousands of programming languages out there. Okay, now, one of the horrible things about this is the circle is hard-coded. You will never create any useful code that does not allow user input. How many of you guys are going to buy a game where you can't control the game? Nobody's going to buy that game, right? That's called being that's called being an observer, right? Not a participant. So we want to have a user input. So that's what circle with input does. And same tricks. Now I went ahead and changed X location and Y location to double because I couldn't stand it anymore. And we need some mechanism that gives us input. And the mechanism that scans things for input is called a scanner. So now we're actually using objects. Now, in order to use it, you have to import it. First of all, how do you know it exists? Well, you read textbooks, you read Java books, you go and Google. You go to the, I think I put up a couple of tutorial references. Tutorials Point is very good. Oracle help pages are good, but they're often overkill. And there's something called W3 Schools, which is also good. And the cool thing I like about W3 Schools is you can, they split the screen into two, and you can code on the left-hand side and hit compile and run, and it will run your code and show you what it looks like on the right-hand side. So all that's very good. Anyway, you import this thing. And again, you're in an object-oriented world, so scanner is an object. There's actually a giant object called Java. That's basically the Java language. And that object contains other objects, one of which is called util, which is short for utility. And that's the portion, the utility object has all of the handy interfaces, the utility, the things that you're going to use a lot. That's what utility means, right? Utility to interact with your operating system. And then there, inside that is an object called scanner, and that's an object that scans things. In other words, it gets a way to get input. Now, when you create the scanner, you're actually creating an object. How do you know you're creating a new object? When you see the new keyword, every time you see the new keyword, you know a new object was created. So you're actually creating an object of the scanner class. Its name, its type is scanner. Right? You're telling the Java virtual compiler, hey, I'm going to make a scanner now. Its input, its name is input. And it's a new scanner. And when you make a new scanner, you have to tell it where the input is coming from. So we'll see later on when we do file I/O, you're going to do this with files. But for now, it's system.in. System is an object, and system.in is the part of the object that handles all the input. System.out does the output. That's why you do system.out print. I don't know why I didn't do print line there. Who knows? Okay, so now we're going to ask the user for the circle parameters. We ask the user for the radius. We ask the user for the X location. We ask the user for the Y location. And the way that works is you say radius equals input. That's the name of the object. And remember, objects are always attributes and methods. So we're saying, hey, object, we're calling the specific method that will receive the next value, and we're going to treat it as a double, next double. So all that's happening here, these lines are replacing the 3 lines of code here where we had the hard-coded values for X location, Y location, and radius. We're replacing it with asking the user for input and then receiving the input. Now, this is lousy code. Can anyone think about some reasons why this is lousy code? This is still just simple examples, right? So it's lousy. What's going wrong here? What could go wrong?
There's no validation.
Exactly, no validation. And we'll talk about periodically throughout the course is whenever you have a user that is giving you data, you have to protect yourself. You have to protect your code. You might have users that don't understand what's going on, and you might have users that are deliberately malicious. It may actually be a cybersecurity issue. One of the ways that people can perform attacks on computers is through publicly available input streams, and they input, instead of putting in good values like they're supposed to, they try to inject codes that will actually access portions of your memory so they can steal data from you, or they will try to inject codes where they can download programs into your computer. So we're not doing any kind of security check. We're not doing any kind of a validation check. So if we put in a bad value, this code will crash, and we don't want that to happen. We'll fix that later in the semester. And then the rest of this is the same, print out. So if I run this thing, the first circle, this is, oh, look at, I forgot to change the name. By the way, how do you create new files? Copy your old ones and modify them. Use your old stuff. Okay, so if I run this thing, or 45, 75, notice I didn't have to put these decimal places in for the double, it'll put them in. And it says there's my center, there's my radius, there's my area, but I could just as easily have done the radius is -10, which is insane for a circle, right? It's hard for me to get a bad coordinate value. So I have a radius of -10, but I have a positive area. And things can get worse. I'm going to put in 10.5. Oh, wait, that's a problem. So my code crashed because it was expecting a numeric value and I gave it a string. And so it said, hey, I'm expecting a numeric, I'm expecting a double, you gave me a string, I'm dead now, I'm just gonna stop running. And notice the name of the error, input mismatch exception. It's actually, these error messages are actually useful. I don't know about you, but I've had software before that failed and it said error code 3012. And I thought, well, that's helpful. You know, I don't know what error code 3012 is, but when you have errors in your Java code, the Java virtual machine will tell you what's wrong and it will tell you where it's wrong. So part of learning to code, because as you all know, you all have had some experience, your code won't necessarily work. Your code will, you need to go through and find out where the errors are. You need to do the debugging, and the error messages are actually quite helpful. So they tell you what's wrong and where. Every now and then the where is a lie. If you have mismatched parentheses, then the where will be wrong because basically it's an issue of the program kept running even with the mismatched parentheses, it kept running until it fell apart. And with mismatched parentheses, it could fall apart in a place different than where the mismatched parentheses were. There's no good way around that. Okay, so this is code that we talked about before. Now, this is not object-oriented design because we don't have any attributes and we don't have any methods. So what I'm going to do is create an actual circle object. So this is our first real object. Now, for your homework 1, I'm expecting this kind of code, like I'm looking at with circle input and first circle. That's how that code can look. You are not required to do anything with objects now because we haven't talked about objects. For homework 2, you're going to do things with objects, but I give them to you already. If you don't want to use mine, that's fine. You can make your own. But I give you objects already, and then you're just kind of filling in the blanks. I'm giving you the skeletal code. So here's what an object would look like. If I really wanted to create a circle object, well, let's think about it. If you want to create a circle object, what attributes do you think you'd want to describe that circle?
Maybe like a radius.
I think radius is a great idea. And
Pi.
pardon?
Pi. The value of pi.
I get pi for free down here, right? Math.pi. But you're right, you need it somewhere, right? But it's already given to us. I would go with x location, y location, and radius. Now you might find other things. Maybe you want to name your circle, you know, then you could give it a name. But x location, y location, and radius. So if I create a circle object, x location, y location, and radius. Oh, I'm going to get rid of that int. Okay. Better be careful. I'm going to have a mistake here. Okay. All right. So what I did is I took these guys out of main. Now they're attributes. And because they're attributes, I put that private keyword in front of them. I don't want anybody having access to these. And in my comment block, I list all my attributes, and I list the important methods that I'm going to create that modify or report on those attributes. So this is how an object commonly looks. You have a list of attributes, and then you have methods. And I usually, again, I'm going to push on you guys to have clear code and reduce the number of comments you need. And so I have methods that do this, right? So I just have a comment that says, here's the beginning of the methods. Now I kept main in here, but notice what main does. It doesn't do anything. It just says, it just prints out and says, somebody called me. But I do have two methods that have actual value. One is calculate area and one is calculate perimeter. So think about it when you're creating an object. And by the way, this is not trivial. You're not going to get this right away. You can work on, professionally on software for a decade and still ask yourself, well, wait a minute, what methods do I need in this object? Should that method go in this object or that object? These are get to be difficult questions. But you can think about, you try to think about, okay, here's my object. What does it need to do? What are the actions that it can perform or that I want it to perform? What are the functionality that I want this object to have? And each one of those becomes a method. So for circles, I mean, there's not much we can do with circles, right? We can calculate the area and we can calculate the perimeter. So those are the methods of interest for the circle. Now you may be able to come up with more. What about moving the circle? That's okay, but we've already got this. So this section that I call setters and getters, basically for every attribute, you have a public method called get, whatever the name of that attribute is. And all it does is whoever asks for the X location value gets it. Because it's returning a value, see, I knew I shouldn't have changed. It has to have a return type that's not void. Right? It's actually returning a value. It's returning X location, and I declared X location to be of type double. Therefore, public double get X location. Public so everybody can see it. Double because it's returning a X location, which is of type double, and its name is get X location because get whatever your attribute name is, and my attribute is X location. You'll notice I have a capital X here. That's a style choice. It doesn't change anything. It doesn't mess anything up. The actual reference to the attribute is here with the lowercase x. I can also have external entities set those values. So again, I want external entities to do it, so it's public. It's not returning anything, so it's void, and then set X location. And this is standard. For every attribute, or virtually every attribute, you're going to have set and get methods for them. And it's so common that in Eclipse, there's a wizard. Once you have all your attributes made, you click on the wizard and it gives you a list of all the attributes and you just do check boxes. Tick, 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 tick. Yeah, give me a setter and a getter for these things. Everybody calls them setters and getters. Their technical name are accessors and mutators. Accessors meaning that you can get them, and mutators meaning that you can change them or set them. So, in your interview, you might want to use accessors and mutators, but then everybody calls them setters and getters. Because the set X location is actually going to modify the value of the X location attribute, we have to give it the new value. So it actually has an input parameter that has to match the type of the thing that you're setting. So since X location is a double, I have double. I like to call it new, whatever, new attribute name, new X location. To me, that seems intuitive as to what that thing is. And so we get new X location. And all of these are going to be this simple. Now, you might ask yourself, well, why didn't we just make the attributes public? And again, remember the big deal with object-oriented paradigm. It's data encapsulation. You're encapsulating your data, you're protecting your data, you're protecting your attributes. So even though I did this, and some, you know, some poor confused person or some malicious person might put in a bad value for the X location. If I wanted to, I could check for that though and reject it if I didn't like it, right? So if I wanted to, I could have, instead of just having X location equals new X location in here, if I only wanted X location to be, say, in the upper right quadrant of the XY Cartesian coordinate system, meaning I could only accept values of X0 and greater, I could check to see if I have a value of X0 or greater, and if it's a negative value for the new X location, I could choose to reject it. So I still have control. This becomes important when you're doing like simulations of aircraft, which, you know, probably should not have an altitude of negative 10,000 feet or positive 6 light years. You get to check for non-realistic values and reject them or put in default values. So notice the code got a lot bigger, but it also got cleaner in this sense. Every method does one little tiny job. Those of you that came from EGR 115, I know you did some MATLAB programming, and you probably did a project towards the end of that course. Roughly speaking, how big do you think your biggest function was in terms of lines of code, roughly speaking? 50 lines of code, 10 lines of code, 100 lines of code? No takers? How about the people that came from CS225? When you did your C programming, what was your largest function, roughly speaking?
I would say the largest function was probably about 20 to 25.
Okay.
Maybe 30.
Okay. That's not bad. In C, the style guide is something like, it is not uncommon to have functions that have 100 lines of code. And when you're getting up to like 1,000 lines of code, then they recommend breaking the function up. In Java, if you have 10 lines of code in a method, that's a pretty big method. We're talking about small little methods that do very specific things. And it can be a little unusual or unwieldy when you first encounter that style, but once you get used to it, it's actually pretty clear, as long as you're naming your methods properly. For example, this method is called calculate area. Without looking at the content of that, can you take a wild guess as to what job that method is doing? Calculating the area. So you name your methods what they do. And then when you're reading your code, you're reading what's happening because you're just reading the names of the actions that are very descriptive. I highly recommend that you write your programs for humans and let the computer worry about itself. If you think you're writing code that's inefficient or maybe difficult for the compiler to compile, I would recommend that as long as it reads better to a human, that's better code. You don't want to use long variable names because of memory. That's not going to affect anything anyway. We used to worry about that stuff a lot. We used to worry about saving memory and not having too many function calls because it reduces the, it adds to the number of execution cycles that the chip has to run. And now memory's cheap and chips are fast, so we don't care about that stuff so much anymore. You really want to stick to writing for humans. All right, now we have a circle object as a class, and the way object-oriented programming works is now you'll normally have another class that actually creates the circle and then exercises the circle or manipulates the circle. So what I have here is something called circle controller. It controls the circle. Now it is not a good object because it doesn't have any attributes. Again, this is just for demonstration purposes, but look what it does. Here I have main, that's my only method is in main, and I create a circle object. I create two of them. I create, again, now this is think of this again as this is inside of a method. So is it an attribute or a variable?
Variable.
It's a variable, thank you. So its type is circle object. Its name is circle1. That's a lousy name. How do we know I'm getting a new object? It's new circle object. And you put these parentheses here. What are the parentheses always telling you?
There's no parameters.
It's no parameters, right? But it's telling you it's a method, right? It's a method that has no parameters. This method, circle object with no parameters, does not exist in here. You won't find it in here. You won't find it in the circle object class. That's Java taking care of you for you. This thing is called a constructor. Why? Because it constructs a new object of the circle object type. So constructors construct a new object. So what I'm doing here is I'm saying, I need a new circle object called circle1. It's new, and I need you to build one for me. So construct one for me. So I'm calling the constructor. When you design your classes, like circle object, you get a constructor for free. You don't have to do anything with it. Now we'll talk about later on how you can actually create your own unique constructors, but you don't need to worry about it. You get it for free. Now that I have this, remember the circle object class file, right? This is a class. A class is a design. It is not the actual thing. It's the design of the thing. So until I say new circle object, all I have is the design. I don't actually have the object, meaning I don't have any memory space reserved or anything like that. So what I do is I say, okay, circle 1, that's one object. Circle 2, that's another object. I can make circle 3, circle 4, circle 5. I can make thousands of circles now if I want to. I can make as many objects of that class as I want. Remember the sheepdog game? We said we only need one sheep class, but we could get 3 sheep objects or 1,000 sheep objects. And then the first thing I do is I print out for circle 1, I print out the area and then I print out the perimeter. Now look how I did that. Circle 1 has a method called calculate area. So circle 1 dot calculate area. In other words, go to the circle 1 object and for that specific object, calculate its area. And then go to the circle 1 object and for that specific object, calculate its perimeter. And notice I'm doing this computation inside the print line statement. And this is what I was talking about earlier when we did this one where I did this kind of a computation inside the print line. It doesn't read well. You have to read it and convince, oh yeah, I know what that is. That's the area. But look what happens here. Since I named it calculate area, it reads well. It's pretty clear as you're reading through it what's happening there. Hopefully, hopefully. So as a human being just reading through this stuff, you can see Oh, okay. We're creating a circle 1, we're creating circle 2, we're printing out the area for circle 1, we're printing out the perimeter for circle 2, for circle 1, I'm sorry. And then I do this. Circle 1 set radius 10, I print out the area and perimeter again, circle 1 set radius 15, print out that again. What's this set radius? Well, remember, inside of our circle object, we have setters and getters for everything. So here's my get radius, which would tell us the radius, and here's my set radius inside the circle object. And again, it's normal for every attribute to have a setter and a getter. So when I run this code, I actually run the circle controller code, and what is it going to do? It's going to create an object of the circle type. Now we're starting to get into an actual object-oriented programming paradigm. What you're going to start to do as you go through building your project and as you go through the homeworks is building not just one file that represents all of your software for a project or for a homework assignment, but multiple object files, multiple classes that interact with each other, that work with each other. And that's the distinction, the big distinction between the object-oriented paradigm and the imperative paradigm. In the imperative paradigm, you start at like in MATLAB, you start at that first line of code, you do it, you go to the next one, you go to the next one, you go to the next one. Here, what you have are a bunch of objects that are interacting with each other. It's a completely different way of thinking about how to solve a problem and how to write code. And yes, it does take a good half a semester to start to feel a little comfortable with that. And then it takes the rest of your life to get really, really good at it. Just like anything else, right? 10,000 hours to become an expert. Okay, so let me run circle controller and put it up next to these lines of code. The first thing we do is we do the area of circle 1, the perimeter of circle 1, and the area is 0 and the perimeter is 0 for circle 1. Now, why is that? Why do you think that is? Why shouldn't it be an error? Because I didn't even set the values for the radius yet, right? It could be an error.
Is it because you set it void? The radius to start as a void?
Yeah, I'm going to say 0 instead of void. Right. So Java does a wonderfully helpful thing. When you create an object, all of these doubles automatically receive the value of 0.0. So when I created the object, radius receives the value of 0.0. If I create a string, it automatically is the empty string. And that's a great help. It's also a horrible, horrible trap, because in some languages, if you don't set the value for something before you use it, you get an error message and the program crashes. And that's good because it means that you must consciously set the values. Here, Java will take care of it for you, which is helpful. It offloads a lot of coding from you, but sometimes you get an error because you forgot to initialize something to its non-zero value, and then you're running calculations and they don't come out the way you thought they would. So that's what's happening there. X location, Y location, radius, they all received a value of 0.0 as soon as we created the object. So as soon as I created the object, I have a circle of radius 0. Of course, its area and parameter is 0. But remember, what is an object? It's attributes and methods. The attributes describe the state of the object at any point in time, and the methods are there to modify the state or to report on them. So I can change the state of circle 1 by setting the radius. I change its radius from 0 to 10. I've changed its state. And then when I do this area parameter again, won't shock you, it looks a lot like pi. Then I change the radius of circle 1 again. I can keep changing the radius of circle 1 over and over and over and over again, right? Once I make it a particular radius, it's not fixed. I can keep modifying it because the circle has state. And then down here, I changed circle 2 just to show you, okay, I have 2 objects, so I can mess around with circle 1 or I can mess around with circle 2. By the way, when you're cutting and pasting like me, the way I created this is I almost certainly did something like this. Let me show you how I can screw this up. I'm going to copy this. And I'm going to change this to circle 2. And then I'll forget to change it down here. And it's like, oh, I keep changing circle 2 and it keeps showing up with the same values. Yeah, that's because I changed circle 2 and I'm asking about circle 1, right? So cut and paste is helpful, but beware, make sure you get all of the references that you thought you changed. Okay, so that's how this works with objects in a very simplistic way. By the way, I kept main inside of the circle object, which means I can run Java circle object. And all it did for main is print it out. Somebody called main. So it may seem weird to you. If you came from the land of C programming where you have to start in main, that kind of means you can only have one main. But notice I have main in circle controller, I have main in circle object. Normally you would not have that. But you can. It's not wrong to have it. How does the Java compiler know, or how does the Java runtime environment know if I want to run the main in circle controller or run the main in circle object? I tell it. Java circle object, it's going to go to circle object and look for the main method. Java circle controller, it's going to go to the circle controller and look for the main method. Usually you're going to have only one, maybe 2 objects that actually have main in them, and the rest don't. They don't need it. But sometimes it's good to have main in these other objects, hint, hint, to put in test cases. So that if you want to test that class, you can put in test cases right in there and hard code them in. Okay, questions? Play with this stuff. The best way, you can listen to me for 10 hours and you're going to learn more by playing with these things for 10 minutes. So please, I've provided you the code, compile them, run them, change them, break them. Try to purposefully break them and see if you can predict how it broke and why. Okay. Last questions before we go. All right, guys, I'll see you on Friday. We'll talk about the project.
Hey, Professor, I had a question. Are these recordings going to be still on Canvas?
Yes, and I'm behind. I'm already finding I'm having I'm behinding on my YouTube uploading in Canvas. Yes, but I'm intending to do that tonight and this evening, is to get organized with that. Yes.
Okay. Good luck, sir. Thank you.
All right. Thanks.